We have people from as far north as Valley Center and as far south as Derby. That's impressive.
Small group, wide coverage.
A lot easier than taking 30 minutes to drive in.
That's true.
Or down from Valley Center.
But you get to go to a building somebody else paid for.
The library?
Yeah.
I think I paid for that.
I just assumed you weren't inside the city limits of Wichita, Larry.
I'm not. That's true. I thought you might pick up on that being the...
You pay city you pay city property taxes for Wichita? That's very generous of you.
Yeah, no. We have our own little issues up here to soak money out of us.
It's like radio. It's like radio clubs. They all have them. Nick's still in the blue room getting his makeup finalized. So.
Joe, in Valley Center, we can have our club meeting and all 8 or 9 of us show up on Zoom. We have better meetings on Zoom than we do in person, I think. We talk more about radio things than when we meet.
Funny how that works. Nick, are you with us?
Yes, I'm here. Can you hear me?
Yep.
All right.
Mark, are you ready to start?
All right. Good evening, gentlemen.
And if you
Nick
fellas
Sharp.
go ahead and mute your mics unless you're talking.
Uh-oh, Larry left.
Larry left. He didn't like that idea of being muted.
Can Nick turn on his camera?
I can, yeah. Yep, I'm getting ready to share my screen here in just a second, so I'll be showing that.
We'll stand by.
Okay, can everybody see the slideshow? All right. Only downside to this, I can't see the chat or anything. So if you want to chime in, please chime in with voice. And I can't see all the participants on here, but if you want me to stop for a question, just please chime in at any time. Nick Sharp, K0NPS. I'm going to be presenting electrical safety, grounding, and bonding for Ham Shack. I'll give you a little bit of background on myself. Started working in electrical and electronics when I was 15. Started working for a light and sound production company. Did that for a number of years, 11 years total. That overlapped into my professional electrical career for a number of years. And I've now been working as a professional electrician for 17 years. I've been a master electrician for 7 of those 17 years and was a journeyman previous to that for 6 years. I'm licensed in Kansas, Oklahoma, and Nebraska. Carry a number of other certificates for electrical testing, installation design and certification of low voltage systems through an organization called BICSI, Building Infrastructure Communication Systems and Design organization. So been doing this for quite a while and really enjoy the electrical industry. So some of the objectives tonight is improving safety, increase awareness around these topics, get you guys introduced a little bit into local and national codes related to the ham shack. Hopefully with this, be able to increase performance of your ham shack with some of the takeaways of it and lower risk of damage to equipment and your house. A couple of things just wanted to go over real quick. Electrical safety, why we talk about electrical safety practices and procedures. In the U.S., annually, the average doesn't change very much year to year, but there's an estimated 30,000 non-fatal electrical shock accidents each year. And sorry, this is not just in the home. This is just recorded data nationwide. There's over 600 people die from electrocution each year, and electrocution remains the 4th highest cause of industrial fatalities. Directly related to residential electrical fires, account for 51,000 residential fires per year, 1,400 injuries in the home, and approximately $1.3 billion in insurance claim damage. One of the things that we will be talking about is going to be lightning protection. Average U.S. Yearly lightning strikes is 22 million. That's not striking structures. That's just how many lightning bursts there are. There's annually insurance claims filed for lightning damage, 307,000. Estimated yearly U.S. lightning damage costs is about 330 million. Lightning ionization channel temperatures are between 15,000 to 30,000 degrees Celsius, about 3 times the surface temperature of the sun. Lightning is a plasma burst of static discharge. The average peak current for lightning is 25,000 amps, and the average stroke is about 4 cycles. So when we talk about electricity, we measure it in cycles per second. So your standard electricity in your house runs at 60 hertz or 60 cycles of the full waveform per second. A lightning strike is only about 4 cycles of that. So we're talking about 1/12 of a second is the actual electrical burst of that. That becomes very important when you start talking about surge protection and clamp time and how quick your surge protection reacts. Because when you're talking an event that's only 4 cycles, you need something that's going to clamp inside of that first cycle to minimize damage. Average channel blast wave energy equivalent to 200 pounds of TNT. Just to go over a couple of quick definitions. These are all straight out of the National Electrical Code. Grounding is connected to ground or a conductive body that extends to the ground connection. Bonding, connected to established electrical continuity and to establish electrical continuity and conductivity. The grounding electrode, a conductive object through which a direct connection to earth is established. So most people refer to it as a ground rod. In the industry, it is technically called the grounding electrode. But that term is also used for rebar that we attach our grounds to that would be poured into a foundation. That is also the grounding electrode. Some interesting things on that. The code requires that in newer construction, you bond a ground wire to a 20-foot horizontal piece of rebar embedded in the building's foundation. Upon testing, almost always that 20-foot piece of rebar in your concrete foundation is going to be a better ground than your ground rod outside. The reason for that is you've got a constant humidity, constant contact below the frost line. So you are not going to have a freeze-thaw effect. You're not going to have drying out in the summertime where your dirt is going to contract away from the ground rod. You've always got that constant contact with it. The next one that we'll be touching on a little bit throughout the slideshow is the inter-systems bonding termination. This is a device that provides a means for connecting inter-system bonding conductors or grounding bonds for communication systems to the grounding electrode system. So this is a little ground bus bar that is now required by code on every residential structure to be placed directly above the ground rod. And this is where you have Cox Communications, AT&T tie-in, or any antenna system that you install would be tied to this inter-systems grounding, inter-systems bonding termination. If you don't have one on your house, it's a great thing to add. They're only like $6 or $7 at Lowe's or Home Depot. And it's just a little clamp-on ground bar that you can clamp on to the ground wire and give you a place to ground. So grounding in the house and the shack. We've got the good. So some of the things about the good, and we'll talk about this style of ground bar a little bit here later. We've got an actual ground bar. You can see that they've got pigtails coming off of it for all of their different pieces of equipment. And you can see the down here at the bottom left-hand corner of it. Can you guys see my mouse?
Yes.
You can see the mouse? Okay. So this number 6 ground wire here, that takes it to the grounding electrode. This is a really good setup way to do it. You're using all proper equipment for that. We get into a little bit of the bad and the ugly. So on the upper right-hand corner, we're using a water pipe as our ground bus. Now, copper water piping is fairly pure copper. It's not as pure as electrical copper, and it's not UL listed to be used as any part of a grounding system unless it's full of water and it's your water main bond. At least in this, they used or attempted to use a UL listed grounding connector, which is a water pipe bond, but they used flat braided cable on it. And what they have going outside of the house and through a window, which is not a really good way to do it, is just a flat tape copper. The big problem with the flat tape copper is you really don't know what the ampacity of it is. It's not been tested for that. And you can see where it makes some pretty sharp bends going through the frame of that window where they've kind of pushed it and molded it into that window. Electricity does not like sharp bends, especially when we're talking high current, which would be what we're here to take care of, is those high current discharges. The next one down, you can see that we're using hose clamps to attach it, and we have a just purely safety problem here of an uninsulated conductor running right in front of a power source, which would be easy if you're plugging or unplugging under there to accidentally hit that or get it trapped in there with a plug and create a direct short. The other problem with both of these that we have is that we've attached the grounding system to a material that can catch fire, a combustible. So you always want to have an insulating material that is non-combustible where that attaches, because if this ground works the way we need it to, it has the possibility of heating up, and we don't want it to start a fire. So here's another picture. We've got more hose clamps. We've got just wire wrapped around wire, multiple different sizes in here. Just not a good way to do it. None of it is UL listed for that, and you don't know what kind of energy force you're going to be seeing in a ground fault type incident. So here's a little illustration that I found that some of this is actually fairly good information, but some of it is a little bit misleading. So in here, we've got a good ground coming in. Hopefully that's a proper wire. They show soldered connections. So that's bad in the sense of the code explicitly says you cannot solder any electrical connections or ground connections. Reason for that is you're talking low temp solder. We have to design the system to be able to take some extreme heat from either a lightning burst or a direct short on there. We do have some good in here of where it enters the house. We have a surge suppression on the coax, and we've got all the pieces bonded. So wanted to show you the difference between a couple of ground buses. I pulled pictures and got all the information off of one website, DX Engineering, a pretty common ham supply place. They sell both of these. So the first one you can see there, it's a UL listed, tested ground bus, pre-drilled for all your holes, comes with the non-combustible insulators, rated at about 20,000 volts on the insulators. It's a 1/4 inch thick piece of copper bus. This guy's only $55. They sell another copper bus that I'm assuming, since it only has 4 holes, you're going to be stacking multiple terminations or ring lugs on each stud. Not the best practice. It's not UL listed. does not have insulating standoffs, so it will be attached more than likely to a combustible material. And for the same money, you're getting a lot less copper ground bar at only 0.098 inches thick. So one of the things in proper grounding, and that first photo I showed you that had individual pigtails coming off to everything, you want to make sure that you only have one pigtail going to each piece of equipment and that you don't bond the pieces of equipment together through this method. That's a great way to get your ground loops. So just take each one back individually to the ground bus and take it to your ground bar. So one thing that we need to make sure of when we're setting up our shack, doing our grounding, if you have an antenna mast outside, is going to be tying everything together with your home grounding system. The reason for that is you're going to get a difference in potential between the two grounds. If one ground rod is high impedance, while the other one that might be out in the middle of the yard gets a lot more rain, your sprinklers on it in the summer, versus the one that's on the side of your house, maybe behind your air conditioning unit, that's not getting hit with a sprinkler, doesn't get the rain. So if you don't have the two of them bonded together, those two ground rods, what can happen is where you have your ham equipment plugged into the wall outlet, and all of that is bonded out to your tower. If you have a ground fault in the house, the preferential ground is going to be at the tower. So everything's going to flow through your ham radio equipment to get out there, to bond or to go to ground. So if you have your stove go bad, your refrigerator go bad, it can sit there and cook your ham radio equipment or start a fire because it's finding a high impedance ground. So NEC, the National Electrical Code, has an entire section on radio and television equipment. In this section, section 810, it specifically even has sections for amateur radio and citizen band transmitting and receiving stations within the home. A couple of sections in there, and we will go over those. So 810 is the rule book to follow, along with a few others, notably Article 250. Article 250 is solely about grounding and bonding. Article 725 is control cable, which has a little section in there specifically about rotator and antenna control cables. Section 820 is about coax and some of the requirements on coax cables within the home. But 810 covers your surge suppression, clearances, and that should be grounding and bonding, not rounding and bonding. So one thing that we have to keep in mind is the NEC is comprised of 9 chapters. Each chapter is written by a different group, and they sometimes conflict with each other, which makes my life a pain in the rear. So every 3 years, a new code book comes out. It takes the Code Council about 3 years to make revisions, take input from manufacturers and from OSHA and insurance companies, see what's happened in the last 3 years. And they're spread out throughout the country. Each group has a chapter and they make their own revisions, and sometimes they do not talk to each other. So right here, per the code, an antenna master support is going to be any structure, metal or otherwise, that holds some sort of radio, broadcast, reception, or transmission equipment, whether it's a beautiful Roan 25 tower out in your yard, a simple pole mast on your roof, or a satellite dish mounted to the side of your house. All of these items have to be covered in the same manner. So some things to take note. They're very serious about the grounding and bonding of all of these masts and supports, and how you treat your antenna lead-in surge protection. So we'll go over both of those. Antenna lead-in surge suppression more here in a minute, but the bonding of it we'll cover here pretty quickly. So coax cables that connect antenna to equipment must comply with Article 820. So the reason why they have a specific article about that is making sure that you're not going to run a standard RG6 or RG59 pretty small intercore conductor coax up to an antenna that you're going to be broadcasting 1500 watts on. So their basis is fire safety and person safety. So they want to make sure that you're not going to run 1500 watts through a coax that is not able to support it. So grounding an antenna mast, whether it's out in the yard or on the house, all outdoor masts and metal structures that support antennas must be grounded and bonded with 81021. Bonding conductors and grounding electrode conductors, antenna mast discharge units are covered in 810.21. The bonding conductor and grounding electrode conductor must be copper or other corrosion resistant conductive metal, not smaller than a number 10 wire. And we'll get into this size here in a minute, because that's interesting that it says not smaller than a number 10 wire, but there's other code rules that you have to take into account that we'll get to here in a little bit when we're talking about coax. So you can see here, you've got to have a ground wire tied to your inter-systems bonding termination, which is this little guy right here on the ground wire. So you can see here all of the masts, the surge suppression for the lead-in wire, all of that ties to the inter-systems bonding termination. So the inter-systems bonding termination, like I said, it's just this cute little bus bar. It's got an open jaw here, so you do not have to unhook your ground wire. It just slips right on. It comes with a plastic back piece so that it's insulated against your house. And then it's got a nice little cover that goes on it. So right here you can see any surge suppression, your AT&T or Cox line coming in would also tie to that. So the reason why we're tying everything to that, once again, is to even out the potential, make sure that there's no voltage differences between the different systems. They all have to be on an equal plane. So in your older homes where you do not have that inter-systems grounding termination, there is specific code for that. Tie straight to the grounding electrode conductor or interior metal water piping system if within 5 feet of point of entry of the building. So they're specific that you have to do it within 5 feet. If you don't have a water line within 5 feet, you need to find the ground rod. So grounding requirements of 810.21. There's 4 requirements that you must meet. Material, the bonding conductor or grounding electrode conductor to the Article 810.21F must be copper or other corrosion resistant conductive material not smaller than number 10. Note, it is not required to be larger than number 6. There's a little caveat to that. When you get to 820, your grounding electrode or your bonding conductor has to be of equal size and not smaller than the center conductor of your coax, but has to be at least a number 10 wire. So if you've got somebody who has run LMR 600 or some pretty big coax up to an antenna that has, say, a number 4 copper center conductor, you've got to run all your bonding in number 4. So just be aware of that if you're running a pretty big coax up to your antenna, all of your bonding conductors have to be of equal size to that. So insulation, your bonding conductors can be insulated, covered, or bare. Supports, the bonding conductor or grounding electrode conductor must be securely fastened in place and must be protected from physical damage, mechanically protected where subject to physical damage, and where installed in metal raceway, both ends of the raceway must be bonded to the grounding electrode. Show you a picture of that. So if you use a metal raceway to bring your ground wire in, you have to bond both ends of that metal raceway to prevent eddy currents from gathering on that metal raceway and heating it up. It'll act like a induction heater if you've got current flowing through there and it's not bonded to ground. So in the right-hand picture, you can see here they've used a bonding connector to ground the pipe to the wire. The other, and frankly easier and more preferred method, is to use PVC pipe, because you don't have to bond it. It provides wonderful protection from abuse for that wire. Primary abuse that you're going to find, especially in residential, is going to be a weed eater, a mower, something like that, disturbing that wire, potentially cutting it or knocking it out of its termination. So service mass supports, little bit of clearance things to go over. You have to make sure that your antenna, lead-in wires, masts, any part of your system cannot be in contact with your service entrance riser or the conduit that your service entrance conductors are encased in. Can't zip tie to it or any means of that. In your home, your coax cable has to be in a separate stud cavity from any power conductors. It can pass through a stud like this and go into a divided box with an outlet, but it has to be run in a separate stud cavity. If they need to share an area, they have to cross perpendicular. You can't bundle them together, or you have to have at least 6 inches of separation. Underground conductors, you have to have at least 12 inches of separation from any utility services coming in that are of line voltage.
I'm going to ask a question on this with that cable wire, because it's something I had to deconflict a few years back. I don't think they teach like those cable installers this, because that's one thing.
No, the guys that run cable for AT&T or Cox or whoever, no, they do not teach them code. They're not licensed. Kansas is really bad about that. What's funny is you go to Oklahoma, and even to install cable TV or an alarm system in a house, you have to be licensed and have certified training for that. So
They probably pay them better though too.
Probably do. So ground rods and how you attach your ground wires. So right here we can see in the upper left-hand corner, bonding separate grounding electrodes. So if you drive a ground rod at your antenna tower, you have to run a minimum of a number 6 ground wire from that ground rod to any other ground rods that you have and back to the main ground rod of your house. That way everything is on the same grounding plane and same potential. Now, like I said, minimum of a number 6 wire on that. If you're looking like LMR 600 or LMR 400, it may need to be a little bit bigger wire. Make sure that you use a UL listed grounding termination. The one right here, that's called an acorn clamp or ground rod clamp. They're insanely inexpensive. They're wonderful guys. They don't really loosen up over time. And what's great about them, they are rated for direct burial. So if you want to bury your ground rod all the way so you don't have anything to trip over, it's rated to go for it. The clamp right next to it is only designed to tie to a water pipe. So you want to make sure that you're not using those for any part of your system. Your water pipe should already be bonded to your electrical service. So on your ground rods, if you're going to drive additional ones, make sure that they are at minimum 6 feet apart because you don't want the electrical fields of your grounding system interfering with each other. So if you can get them a little bit further apart than 6 feet, the better off you are. And for ground rod installation, you've really only got 3 options. One, it has to be minimum of 8 feet in length, has to be either straight up and down. If you encounter bedrock at, say, 7 feet, you can put it at a little bit of an angle, but the maximum angle is 45 degrees, or you can dig a trench 30 inches deep and lay it in there flat. I don't know why they have this rule of straight up and down 45 or flat. I don't know what a 50-degree angle would hurt anything if you can lay it flat in a trench, but I'm not the one who writes the codes.
Is there a maximum distance between those?
No, as long as they are bonded together. If you put them at the 4 corners of your house and ran a wire all the way around your house, that's called a ground ring. But yeah, then they could be 30, 40 feet apart. Then you need to bond each corner to, say, the foundation of your house if feasible. But a ground ring is a really good protection method for your house, but it's also kind of a pain to put in. And we have really good soil in Kansas, depending on where you are. Derby is very rich with clay, so it keeps a moisture level year round, which is great for grounding. You go over to Hayesville and it's very sandy. So you'll see the implementation of more ground rods in Hayesville versus Derby just to get a grounding impedance of less than 25 ohms.
Now,
so
I was going to ask one more question on that previous slide. It looked like, I don't know if it's just the slides or whatnot, but do you have to bond underground?
Yes and no. So if it's against a house where it's feasibly protected from damage and not a tripping hazard, you can have a maximum of 3 inches of your ground rod exposed, or where it penetrates a concrete slab, you can have 3 inches exposed above.
Well, I didn't know if the bonding had to be in ground as well, or if you could even like put a cup down in there to protect that if it was...
Oh yeah, a number of times we've taken like an 8-inch piece of 4-inch PVC pipe and we created like a little access well for it. But then you have to mark it and let them know that the grounding electrode is in there. But yeah, having them fully buried is not a problem, but it's not required that they're fully underground unless it's out in the middle of the yard and it's going to be, you might hit it with your lawnmower and damage the grounding electrode.
I thought it'd be kind of a pain for maintenance, but
hopefully you shouldn't have to access your ground rods ever again. If you use the correct clamp, get it nice and tight, they're going to be good for a long time. The other method that you can use to affix to it is called an exothermic weld. You clamp a graphite mold around the rod, stick the wire in there, and then you use a thermite charge with cadmium, and it permanently welds in about 2 seconds the ground wire to the ground rod. Pop it off, let it cool down, and go on your business. That is the best way, but it's not something that's readily available to homeowners. So, antenna discharge units. So we've got 2 sections of here, 810.120, and then 810.155. So 810.120 talks about your discharge units or surge protection for your antenna systems. There's 3 main bullet points under is where required. It's each lead-in conductor from an outdoor antenna shall be provided with a listed antenna discharge unit. Has to be listed by the recognized group in your area. That's generally meaning UL listed. Location, the antenna discharge unit must be located outside or inside the building nearest the point of entrance, but not near combustible materials. If located inside the building, the leading conductor shall not be in contact with combustible materials. So if your surge protection units are inside your house, the entire path that coax cable takes going in cannot be in contact with insulation, siding, 2x4s, or any other material, and nor can the antenna discharge unit once it's in there. The final requirement for it is the antenna discharge unit must be grounded. So to the top of the slide, 810.55, entrance to building, specifically is in a section for amateur radio transmitting stations. Lead-in conductor for transmitting stations shall enter building by one of the following methods: through a rigid, non-combustible, non-absorbent insulating tube or bushing, through an opening provided for the purpose in which the entrance conductors are firmly secured so as to provide a clearance of at least 2 inches to any combustible material, or through a drilled window pane. That last one caught me off guard when I was reading it in the code book, because I don't know anybody who's going to drill holes through the glass of their window to run a coax, but it's approved. You can do it if you'd like to. So some pictures of some antenna discharge units. This upper left-hand one, it's a really neat device from DX Engineering. Goes right on your ground rod. I've got a problem with it, though, in that you've got more than 3 inches of ground rod exposed, which is a code violation. Your grounding attachment, that plate is really cool, but it's not UL listed for the purpose. And it might have the capacity for it, but I don't see a place for it to bond to another, to your entire system. So be very careful of some products out there and make sure that what you're getting is UL. The reason why products need to be UL listed is somebody comes up with a design and says, hey, I'm going to have this cool plate that clamps to a ground rod and it holds my antenna discharge or surge suppression units, and we're going to sell it. Well, UL, when they send it off to them, says, okay, we're going to essentially hit it with lightning and make sure it doesn't blow off the ground rod, it doesn't melt, that it does what you say it's going to do. typically, from what I've found, companies that are unsure of whether or not their product is not going to pass the UL test don't submit their products for UL testing. It's not a huge cost to get an item UL tested. We had to have a light fixture that an architect wanted custom built, UL tested for a house a couple years ago. And I want to say it was only about $250 or $300 for it to be UL tested. And it failed. And it was a really good thing that it was sent off because it caught the insulation that it would have been in contact with on fire in the UL test. So it's, as we can see earlier, we're talking a $2 difference on a ground bar to get one that's UL tested, and it's going to do what they say it's going to do. So this box right here, you really like the ingenuity in it. Things are laid out well. Gives great weather protection to the antenna discharge units. Make sure you're not going to get any water into your connections. But there we see that copper tape again. Not correctly fastened and not even the correct material for bonding your system. Remember, it's got to be a minimum of a number 10 wire. So right here, we've got a really cool innovation that somebody has, I guess, for storm protection. Totally disconnects with the flick of a switch all their antennas and their control cable. And they've got their antenna discharge units there. Problem is the whole thing is in contact with combustible materials inside the home. Not seeing a ground wire connected to it. So if their antenna gets hit, where is that voltage going to go? It's not going to go to ground. It's very possibly going to jump the gap, that short gap, over to those drawer slides and into their ham radio equipment, unlike what they're wanting it to do. Over here, there's that DX Engineering ground bus, actually a pretty decent application for it, in which it's connected to brick, a non-combustible material. All in all, not a bad installation, but you've got both sides of your antenna wire in one conduit. Problem with that is a lightning strike is going to induce current and voltage on any other conductors that it is run in parallel with. So if you get a lightning strike, even though you have some really good surge suppression right here, you're still inducing quite a bit of voltage, more than enough to do damage to your ham radio equipment just by running all those cables in parallel with the ones coming from your antenna. So make sure you've got really good separation between your lead-in conductor from your antenna and your coax cable coming off your surge suppression to your ham radio equipment. Surge suppressors. This is something that can be, looking at some of the QRZ forums, can be a hot topic of, oh man, polyphaser, they're the best. No, alpha delta, they're way far superior than anything polyphaser's ever come out with. Oh, for the money, just get MFJ, they work. I'm going to tell you right now, anything is better than nothing, but none of these pictured are UL listed. None of them have been tested by UL to do what they say they're going to do. I may be slightly wrong on that, but I researched the polyphaser, the alpha delta, and the MFJ, and could not find on any of their spec sheets, their website, any listing of UL certification on them, saying that they'll do what they're going to do. The MFJ right here, you can see it's got a little ground lug on it for a 14 gauge wire. the ground lug that they provide isn't even code compliant for that. Where your polyphasers and your alpha deltas, those are bulkhead mount and can accept a much larger grounding conductor. The one in the upper right-hand corner, I don't even know if that'd take an 18 gauge wire on that little ground lug, but that's a surge suppressor that's selling on Amazon, something that I would actually stay as far away from as I can. So talking about surge suppression, there are brands out there that make UL listed surge suppression for your coax. Erico Caddy is one. They make it for broadcast services. They have N connections. They've got the PL connectors. So whichever kind you want, they're rated 1500, 2000 watts. So they're a phenomenal connector. I don't sell them. Anything that you can do to really protect your home. And this is an older picture. Their newer models look a lot like the polyphasers and don't have this goofy little ground lug on it. But when we're talking about surge suppression, it needs to be more than just your coax cable coming in. That's the only one that's required. I take that back. Up until 1 year ago, that was the only one required. The 2020 code brought in a requirement that all new homes must have surge suppression at the main disconnect or at your main breaker panel. Sedgwick County, City of Wichita has been more than kind enough to say, we don't like that rule. That's going to be the choice of the homeowner, whether or not they put surge suppression on the whole house. But it's really not a horribly high cost to do that. You can get a really good surge suppression unit for your whole house for about $150 for the unit. There's some that are UL listed and very good units that are smaller than that. So one thing to look at it, it's hard to see in this picture. So this unit right here is a whole house surge suppression. It's rated for 36,000 amps. That's how much of an energy hit it will dissipate to ground. You'll find some that are available at Lowe's, Home Depot that are only 10,000 amps. But remember, we were talking a lightning strike is on average about 25,000 amps. So, being that 50% above that, we always talk about engineering safeguards being 50% or 100% above nominal is always a good thing. So, but only being 50% of the nominal at a 10,000 amp rating, you're just throwing money away. So make sure what you're getting is going to protect you and protect your home. But putting one on the main breaker panel is only your first line of defense. You need to make sure that you've got a rated surge suppression at your devices, like these power strips here. Not all power strips are surge protectors, and not all surge protectors are good. You need to make sure that if you get a surge protector strip, that it is a fail-safe model. A lot of them, they use MOVs for capturing the surge. And once those MOVs fail, they're just out of the circuit, but your surge protector still works. It gives you no indication that it's dead. There's a number of them out there that as soon as the MOVs are at end of life, the whole power strip stops working. So it gives you a really good indication when you no longer have protection. So for all of your other equipment, they make really good, there's companies that make really good surge protection for data lines, phone lines. These are a rebuildable surge protection that you can use on your rotator motor, control cable, and antenna control cables. They've got multiple different models for different voltages and different things that you need. And you can just pop the little MOV module out of it and put a new one in. If you take a close enough or a direct hit that it fries it, you just pop the module in and out and you're back up and running. So any questions on grounding, bonding, surge protection?
I've got one, Nick.
Yeah.
I've got a friend, not me, a friend.
Okay.
I've got a friend.
A friend.
He's got his ham shack on one side of the house and his service entrance on the opposite side of the house.
Mm-hmm.
He's got a ground rod for the ham station that he's tied off to.
Mm-hmm.
That ground system, that ground point is not tied to the house ground system on the opposite side of the house, the service entrance. They need to be tied together. That's what we learned again tonight, right?
Yes.
Okay. My question is, if he goes out and buys number 6 wire,
Mm-hmm.
is there any problem with tying those two together running through the house rather than around the outside from a code perspective or best practice?
No, there's not. I would say you would be, if it's running through the house, I would run insulated number 6 so that you don't, if you run bare copper number 6, you really need to insulate that cable from any combustible materials.
Right.
Not much of a cost difference really from number 6 bare copper to insulated number 6 stranded. And running number 6 stranded wire out there, you're going to thank yourself for it. But, you know, you really could run it on the outside and just push it into the dirt with a shovel right along the foundation too. It does not have to be 18 inches deep in a trench. It can be just a couple inches deep so that you're not hitting it with the weed eater or the lawnmower.
And is that the better practice? I mean, should he tell his spouse that it's worth the extra money to run the longer distance?
I would, if it was my house, I would run it on the outside. Now, if you have an unfinished basement and it's a easy straight run, running it through the house, go for it. The shorter the run length, the lower the impedance and the better the ground system is.
Okay. Thanks. I think that's what he'll do. I mean, I think that's what he'll consider doing.
Any other questions on any?
Oh, yes. I have a question.
Mm-hmm.
I've discussed this with guys down at Westar.
Mm-hmm.
They don't seem to think it's a problem. My electric service comes into my mid-60s house,
Mm-hmm.
and I know it's not up to code. Someday I'll either bring it up or they'll push me to when I sell it, like my neighbor just went through.
Mm-hmm.
Don't ask. Anyway, there's no ground over there. The house ground is grounded to my copper water pipes, which go out to the meter. I've been here 35 years, so and the house isn't that much older. So I'm comfortable with that. That's a decent ground at this point and hasn't been disconnected. But the AT&T and the Cox and these guys that come in over there near where the electric drops from the pole have run a wire over and bonded to the metal, circular metal around the power drop from the pole. And they tell me that's their common, Westar.
Westar said what?
It's their common.
So the metal on the outside is going to be code. It's called the grounded conductor. So
where's it grounded?
The grounded conductor is what we typically call, or what most people call, the neutral. So from Westar or from any utility, they do not bring a grounding conductor or a ground to your house. They bring 3 conductors. They bring 2 hots and a neutral. The neutral is the grounded conductor, because at their transformer, they have a ground rod driven there, and they bond the neutral to ground. So it is grounded. It is at the same potential as ground. If you were to put a meter into a wall socket, you would have 0 volts from neutral to ground, or you should have 0 volts neutral to ground. Tying to that was an old method that is no longer allowed. You have to provide that inter-systems bonding termination, which if you don't have a grounding electrode or grounding system in the house, then you'd have to run a wire from that water pipe to that inter-systems bonding termination for them.
So I need to run from my external ground rod driven 8 feet in the ground. I need to run a number 6 wire around the patio 40 feet over to that piece of and put another ground rod over there.
So it's hard to picture your house. So Cox and them ran to where your electrical service comes in. How far from your electrical service is your breaker panel? Is it on the other side of it?
No.
The wall?
No.
Oh, your breaker panel is on the other side of the house from it?
Not really. The meter entrance to the house is probably 20 feet east and 4 feet north, 5 feet north of the breaker box. The breaker box is in the garage.
Ah, okay. So that's another problem. You can only have a maximum of 10 feet total of unprotected service entrance cable in your home. So
unprotected means in a conduit, essentially?
No, unprotected is there's no overcurrent protective device. Your meter, so from the pole where the transformer is through the meter, there's no breaker there.
Right.
So they may have 400 amps available to feed 4 or 5 homes on that pole. Well, if something were to go wrong in that 24-foot run of cable that goes from your meter to your breaker panel, that wire is only designed to handle maybe 100 amps, I'm guessing, from a mid-60s home. But now it has 400 amps available to it with nothing to turn it off in the event of a short circuit. So, yeah, any anything that were to happen, it's a high fire hazard because of that run length of cable.
So in essence, I need to put a surge protector and a breaker at the at the
meter.
At the meter.
Yep, which is now code as of January 1st of this year. For firefighters, you have to have a circuit breaker or disconnect right next to the meter so they can turn it off in the event of a fire.
That makes sense. I like that.
Yeah.
I don't know that I'm going to like the cost.
But yeah, they come out with new stuff all the time. So one that really threw a bunch of people for a loop and got them a little bit aggravated is any circuit 50 amps or less, whether it's 120 volts or 240 volts, has to be GFI protected. That has a receptacle.
Okay.
So
yeah,
that new code now means your dryer, your range, technically even your air conditioner, because it has a disconnecting means outside and it's an outside appliance, a welding receptacle in your garage, all have to be fed off of GFI breakers now.
Oh.
Yeah.
Where you're linear.
Yeah. I was at a code update and people were like, you're going to put us out of business with this added cost. It's like,
I've heard that before.
Yeah.
I've heard that before.
Amazingly, most of them are still in business. They learn to pass that cost on to the customer. But yeah, there's a lot of rules that you're just sitting here scratching your head going, man, that really doesn't make sense. But this new rule of the disconnect outside next to the meter makes a lot of sense. It's a really good thing for the firefighters so they can safely enter the homes.
I think I need to talk to the bank. I had a lot more to do than I thought.
Tell you,
Appreciate your answer.
This job.
Not a problem.
This job
Got a quick question on the bonding wire, that 6 gauge. Can it be solid or stranded?
Yes, as long as the termination is rated for it. And all of your acorn clamps for like going to a ground rod will say on there if it's solid only or if it's rated for solid and stranded.
Okay, thank you.
Mm-hmm. John Van Water, go ahead.
Yeah. I guess it sounds like what I need to do is have somebody come over and evaluate my house, because I've got an older house with a newer addition, and the newer addition caused a lot of changes to my electrical.
Mm-hmm.
I know I have a disconnect next to the meter now, but I don't know is how well my grounding is now. My entrance for all my coax is using a straight one of the straight barrel connectors through a stud wall. But I have the surge protectors on the outside, and I have a grounding rod just outside, and I have it connected through the wall with I think a 10 gauge wire clamped onto a water pipe.
Okay.
And so I don't know if that's enough of a connection or not.
No, it'd need to be tied to the other ground rods because you can't have multiple connections to the water pipe. And what's interesting is code is really getting away from years ago. Your main bonding of ground was to the water pipe, water's conductive. Your pipe underground was always metal, but now they started putting PEX pipe or plastic pipe from the meter up to your house. Well, now it's not conductive. So tying to a piece of, even if they put a small segment of copper pipe in the house and for you to bond to, it's good because it bonds the water itself to ground, but now you're not able to derive your grounding system off your water system like you used to.
Okay. Well, I guess I'm going to have somebody come and take a look at it. Thanks.
Not a problem.
I got a question for you. It might be an odd question. My house is pretty much skinned in metal. Is there anything additional I should be looking at for grounding?
I would make sure that metal roof, metal siding is bonded. I just went out to my cousin's house in Cheney, and he has a Morton building.
Same as I've
got. And insurance is calling it an electrical fire, but he had no electricity in that corner of his Morton building, and one entire 6x6 post burnt up completely. And on the other side of the Morton building, the ground lead for one of those radio frequency dog collar systems where you bury the wire was fused and welded to the skin of the metal building. So we're pretty sure it was a lightning strike that hit the building, and it totally incinerated this 6x6 post and did not burn up a single other thing within 2 feet of it, but arced some items on the other side of this 40 by 60 building. So yeah, I would make sure that metal skin, while it acts as a really good Faraday cage, make sure it is bonded to ground.
How do I do that? Do I just kind of like grind off an area and then just bolt through it, or what?
Yeah.
All right. Well, that's all I really had.
Yeah, Nick.
Hello?
Yeah, it's Jim.
Yeah.
And what I may do, if it's all right with you, our house was built in 1926.
Mm-hmm.
Meter on the outside, I don't. It's within just a couple of feet of the breaker panel on the inside, but I don't think it has a shutoff. I'm not sure how the grounding was done with that, or if it was in 1926. I know that probably in the 50s and 60s, somewhere along that line, that the service panel was updated to a 200 amp service.
Mm-hmm.
But what I may do is bring in sometime when we can actually physically meet and show you a floor plan drawing of our place, as well as a couple of photos I can take from the outside and kind of where maybe some potential issues and how to address them might be. Would
Sure.
that sound reasonable?
Yeah. I don't mind taking a look at some pictures. So.
Yeah. Okay. Yeah, right now my radio is set up in the living room, which is way away from the breaker panel, but I'm using a J-pole. It's in the house, and haven't really put a mast or anything structured for an antenna outside. So a lot of things are fluid, and I can maybe plan to change position of the radio if that becomes an issue. That sound good?
Yeah, yeah, just yeah, next time we can get together, let's just we'll take a look at it.
All right, I'll try and pull together some materials and keep it in a notebook ready, for when we can meet. All right, thanks.
Jim, I'd recommend you hire a professional to take those pictures.
Yeah, I was going to ask you if you'd come do that.
Oh, yeah. Welcome, John.
I finally did get into the meeting.
Well, if there's no other questions, we can just, I guess, ask, since a good portion of us already know what the club business are. Do the rest of you want us to go over like the Secretary's report and the Treasurer's report?
I think from a secretary standpoint, the only thing I want to do is reiterate the results of the election, if that's all right.
Oh, sure.
Okay. After all the dust settled, we had a three-way tie for junior director. And what we decided to do was Terrence, our vice president, met with a couple of the contenders over lunch and kind of worked out a compromise with them that they were happy with, and then passed the results on. And then we did a motion vote over email with the board to finalize the results. And so as of now, of course, the president, vice president, past president, secretary, treasurer, and senior director were all only single candidate. So it was just the junior director. And out of that, Jarrett Green, KB0 ICT, is now our junior director. And we have Bill Perkins, W0HOH, is a at-large member of the board. So that is our 21 officer pool. That's really all I have.
All right.
Any questions? I had a question, maybe of Mark or what's a remnant of board. This year in February for officer installation, and what is the COVID situation due to that? Are we doing an installation? Or?
Not this year, just because dealing with COVID and so forth, and trying to find a place that could host us and whatnot. So we decided not to really explore that too much, because I think we knew what the answer was going to be on that.
Yeah, that was pretty much what I would expect, but thought I could ask.
Yeah, I think we contacted the restaurant a couple months back, and even then there were just too many unknowns, so we decided to cancel that.
Okay, yep.
Nick, I don't know if you had anything for from the treasurer's standpoint.
Yeah, I can do a quick overview. Been trying to get the last year wrapped up for the most part, but I ran January real quick. Okay. So far for the month of January, we had $250 in dues come in, $3.89 in interest income. We had $47.40 in expenses. The majority of that is the Derby Electric. Giving us remaining balances restricted for 2022 budget, which is the dues coming in this year. We have $250. Remaining budget for this year, standard expenses, $2,192.60. Derby repeater fund sits at $1,900. Beaumont repeater fund is $1,000. Emergency fund is $2,204.57. And general fund is $9,218.44. With a total funds allocation of $16,765.61.
All right. Well, any questions from anybody? All right. I don't know if Mr. Locke, John, if you have anything from the repeater perspective.
You're muted, John.
Oh, looks like he just dropped out. So I guess that's a no. All right.
Mark, just as a point of information, next month we'll be meeting on March the 3rd. I will confirm with the speaker tomorrow, but scheduled is Cody Shavat with the Sedgwick County Emergency Management, and he is the training and exercise officer for that group, and he's going to be talking about severe weather safety and storm spotting information.
All right.
I had to go out and come back in before computer would let my microphone work. This is KF Sterling.
Well, I didn't know if you had anything, John, from the repeater trustee's perspective.
Only mainly that the Great Bend Club got their Wires X room back up and operational, and so our Wires X repeater is now linked full time to the Great Bend room on Wires X, which then also crosses over to the Central Kansas Talk Group 31204 on DMR, and is also connected to the Great Bend YSF reflector. So it gives people with Wires X or DMR capability or a fusion capability multiple ways to be able to access the other hams in the Central Kansas area. That's the only thing I've got really that's new, and that was Great Bend had that down for several months, and we're glad they got it back up. Seems to be working better than it did before. There's less lag in crossing over between systems, so looks like that's going to be a pretty nice now that it's going again. Hopefully we can start advertising it and pick up a few more people on the DMR and Fusion Net on Sunday evenings.
Well, it sounds like I need to get my hotspot up and running again.
Yeah, because if you got Fusion with a hotspot, you can check into the system via the YSF reflector. If you got DMR, go in that way, or if you got or if you have access to the repeater, or if you've got your own WiresX node by running the software on your computer connected to your Fusion radio, then you can get in via WiresX. So multiple ways that can all be connected together there.
Sounds like a class opportunity. Show how to connect to Central Kansas via digital.
Yeah, I need to get them to tell us how they're making the bridging work. I don't have a clue how they make that happen, but they've got it working fairly well.
I don't know. Some of these hotspots have some decent software or some configurations going to the YSF to DMR. I haven't looked into it enough to be smart enough to talk. It's still magic.
Yeah, I don't have anything else. I don't have anything related to our repeater systems per se. Nothing's really changed there.
Alrighty. Well,
Good to have you here, John.
Yeah, I managed to forget till then when I finally did remember, I thought, well, we'll go see if anybody's still there.
Well, I am recording this, so hopefully it comes out well, and hopefully by tonight or tomorrow morning, depends on how long it takes to encode. I'll see about having a link thrown up on the Facebook page. So, because it was a really good presentation by Nick. So, I have a.
Yeah, I'll be interested in.
Say again.
Oh, I was just going to say I'll be interested in seeing that because I missed about the first 10 minutes just trying to get be allowed to be in it in the meeting.
Well, I just feel like I have a whole bunch of work now to do again, walking around my house and checking where things are grounded. So, be good times, all before spring. Well, does anybody else have anything they want to bring up?
I guess I would just say that, Nick, we don't usually applaud under a Zoom setting. So other than that, you'd get a standing ovation, I'm sure.
Good.
Thank you, guys.
It was very informative.
Yeah, thank you.
All right. Well, if we got nothing else, we'll go ahead and call it quits for the night.
7-3, stay safe.
Yep.
Have a good evening.